How exactly will the laser weapon pods mounted on the J-11B fighter jet change the rules of future aerial combat? When this silent beam cuts through the sky, does it signify that fighter defense has evolved from passive evasion to an era of active interception? Recently, a CG animation featured in a report by CCTV's military channel caused a huge stir among military enthusiasts. The footage depicted a J-11B fighter jet carrying not conventional missiles or auxiliary fuel tanks beneath its wings, but two bulky laser weapon pods. The official report's phrasing, "the installation and application of laser weapons and other equipment," signals China's emergence as one of the world's few nations to achieve operational deployment of laser weapons on fighter aircraft. This not only reflects a leap in China's military technology, but may fundamentally rewrite the rules of aerial combat. Based on the CG footage released by CCTV, these laser weapon pods are quite substantial in size, comparable to the 800-liter auxiliary fuel tanks mounted under the J-10's fuselage. They feature an optical window at the front and exhibit a streamlined design. Such a large pod requires carriage from the heavy load hardpoints on the inner wings of the J-11B, indicating its substantial weight. Unlike traditional missiles, laser weapon pods lack warheads and explosives, relying instead on highly concentrated energy to destroy targets. This operating principle enables revolutionary combat methods. The core advantage of laser weapons lies in their unparalleled speed. Traveling at 300,000 kilometers per second, light requires virtually no time from lock-on to impact. Even the fastest missiles in modern air combat, reaching only 6 times the speed of sound, are snail-like by comparison. When an enemy pilot presses the launch button and the missile screams toward its target, conventional countermeasures are limited to evasive maneuvers or deploying chaff. Now, however, the J-11B can patiently wait for missiles to enter laser range before silently firing a beam. In an instant invisible to the naked eye, the missile's guidance system is incinerated, leaving it rudderless. This light-speed defense capability fundamentally reshapes the offensive-defensive logic of aerial combat. Beyond speed advantages, laser weapons offer astonishing cost-effectiveness. A single laser pulse costs roughly $1, whereas an air-to-air missile can easily run into hundreds of thousands or even millions of dollars. Using missiles to intercept inexpensive drones is like using a cannon to swat a fly, a problem laser weapons perfectly solve. In counter-drone operations, laser weapons demonstrate even greater value. With a per-shot cost of just a few dollars, and the ability to sustain continuous operation as long as power is available, they serve as a defensive weapon with infinite ammunition. More crucially, China's laser weapons have been developed into a series ranging from 30 kilowatts to over 100 kilowatts. At 150 kilowatts, they can fully meet short-range air defense requirements. Integrating laser weapons onto fighter jets poses immense technical challenges, chiefly due to their enormous energy demands and heat dissipation issues. Laser cannons are power-hungry beasts, especially high-power models capable of burning through missiles, with a single shot consuming energy equivalent to dozens of household air conditioners running simultaneously. Conventional fighter jet power generation systems simply cannot meet such demands. To address this, Chinese researchers developed an integrated energy electromechanical system that functions like equipping the fighter with a smart power bank and super-efficient heat sink. This system routinely stores excess electrical energy, releasing it instantaneously when laser weapons need to fire. Simultaneously, it rapidly dissipates the immense heat generated by laser emissions, preventing damage to aircraft systems. This breakthrough technology is precisely the key to China's practical application of airborne laser weapons. From an operational perspective, the J-11B carries 2 laser pods, mounted beneath its left and right wings respectively. This configuration creates a forward defensive arc specifically designed to counter threats approaching head-on. Unlike the 101KSO laser-directed countermeasure system on Russia's Su-57 fighter, the J-11B's laser pods are larger and more powerful, suggesting a more advanced operational purpose, intercepting radar-guided air-to-air missiles launched by enemy aircraft, primarily serving as a defensive weapon for beyond visual range air combat. In modern combat where beyond visual range engagements dominate, fighter jets face a far greater probability of encountering radar-guided air-to-air missiles than infrared-guided ones. This design philosophy reflects a combat-oriented approach. The advent of laser weapons is reshaping traditional air combat paradigms. Beyond visual range engagements once hinged on who detected targets first and fired missiles first. Now, even if locked onto by enemy missiles, laser weapons can intercept them at the final stage. Drone swarms once posed a headache, as intercepting these low-cost drones with expensive missiles was simply not cost-effective. Laser weapons solve this problem precisely. As long as the fighter has sufficient power, it can fire continuously, making dealing with swarms of drones no longer a challenge. Furthermore, laser weapons produce almost no noise, smoke, or discernible trajectory, enabling them to operate covertly in electronic warfare environments and achieve surprise effects. In the global laser weapon competition, China has established a significant advantage compared to the US Helios system and Japan's 10-kilowatt vehicle-mounted systems. China not only possesses mature equipment like the 10 to 50 kilowatt Silent Hunter, but also boasts combat-ready testing records for its 300-kilowatt ship-based systems. Moreover, models like the LW60 achieve energy efficiency 30% higher than comparable international products. More importantly, China has achieved a land-sea-air full coverage development strategy. Land-based models have been exported to Saudi Arabia with proven combat effectiveness, vehicle-mounted variants debuted in military parades, and ship-based systems completed sea trials, forming a multi-scenario, serialized technological framework. Of course, laser weapons are not omnipotent and retain inherent limitations. Water vapor and fog in the atmosphere absorb laser energy, drastically reducing effective range. In coastal environments with 70% humidity, the effective range of a 300 kilowatt laser may plummet from an ideal 100 kilometers to just 20 kilometers. This means laser weapons become significantly less effective under complex weather conditions. Currently, laser weapon power remains limited, making them incapable of directly destroying enemy aircraft. Their primary role is defending against incoming missiles. Achieving direct attacks on fighter jets requires major breakthroughs in power output. The United States began researching laser weapons early, but has yet to achieve practical deployment on fighter jets. Its self-defense high-energy laser demonstrator program was terminated in 2024 and transitioned into technology reserves due to technical bottlenecks, like heat dissipation and power density. In contrast, China's breakthrough lies in practical application, directly integrating the system onto its mainstay fighter jets while resolving energy supply and heat dissipation challenges. Although laser weapons currently serve primarily defensive roles, their future development potential is immense. The Integrated Energy Electromechanical System, mentioned in the CCTV report, not only supports the current J-11B but also lays the foundation for future sixth-generation fighters. As laser power continues to increase, it may evolve from a purely defensive weapon into a primary weapon capable of directly attacking enemy fighter sensors. From a broader perspective, the J-11B's integration of laser pods signifies more than just the deployment of a new weapon. It represents a pivotal step forward in China's practical application of airborne laser technology. While nations worldwide continue to explore the feasibility of airborne lasers, China's J-11B has already taken to the skies equipped with laser pods. This revolution in the speed of light is not merely the introduction of a new weapon. It signifies a fundamental transformation of future air combat rules. When missiles can no longer guarantee hitting their targets, and when fighter defense shifts from passive evasion to active interception, the history of aerial combat is being rewritten. This beam of light, crystallizing human ingenuity, is entrusted with the mission of safeguarding peace. It illuminates not only the future direction of modern weaponry, but also the resolute strength of a nation in upholding its sovereignty and security.